All right, welcome back to Hitchhiker's Guide to the Solar System. This is an investigation into our solar family. We are now on part 3 out of 5. You guys are almost there. Today we're going to learn about the gas giants. So we're continuing learning about the planets. After this, we're going to talk a little bit about some things called Neptunian objects, like Pluto, the planet that has sadly become an X-planet. We're going to learn about the Kuiper Belt, we're going to learn about the Oort cloud, but today we're going to focus on gas giants. So part 2 of the Wanderers is the gas giants. I also wanted to show you guys this image right here. In the last lesson we talked about why planets were named planets, which was Greek for wanderer, and this is an image that shows the path of Mars. If you stare at it up in the night sky and you follow it for a couple months, it looks like this. You can see these are stars in the background right here that are very far away from us and they don't move at all. However, what the Greeks saw was this planet coming in right here, and they actually thought it was a star at the time that was moving a lot compared to all the other stars. So they called it a wanderer, and in their language, wanderer was planet. So that's why they got called planets. It stuck. They are not actually stars, though. They are different. They don't have nuclear fusion going on, and they are a special thing that we call planets. We stuck with that name. Okay. Essential questions today. This is what we're going to be addressing. What are the basic components of the solar system? So as I said before, with this guide that we're making, we're going to focus just on some of the basics, what planets are out there, what objects are out there, and then after this we're going to do a report where you're going to delve into the specifics of some object of your choice. And we're going to create a scale model of the solar system in the hallway. But for right now, we're just kind of going to get the basics out of the way, learn the names of the planets, learn about some of those other things that are floating around out there. So today, or I should say, lesson 1 we did the sun. Lesson 2 we did terrestrial planets, Mercury, Venus, Earth, Mars. Today we're going to wrap up all of the 8 planets with Jupiter, Saturn, Uranus, and Neptune. Okay. So again, we're going to go back and look at our definitions. We've got 2 types of planets, terrestrial and gas giants. And we said when we think of terrestrial, we want to think about the words terrain and terrarium. Terrain is the ground that you're walking over, the soil, the, it could be sandy, it could be muddy, but it's earth. And then terrarium is what Trouble the gecko is in the back of the room. He's in a terrarium. It's filled up with sand instead of water. So terrarium, terrain, terrestrial, they're all soil. They all have earth related to them. So we're also going to think about terrestrial planets being solid, and a great example is the one that we're on right now, planet Earth. So whenever you hear terrestrial, you're going to think something you can stand on. Terrestrial planets are planets you can stand on. Today we're talking about gas giants, which are definitely a lot different. We are going to think big. They're giants, they're big, they're cloudy, they're gaseous. Again, the nice thing about the naming conventions is it kind of tells you what it is right in the name. It's a big thing, and it's made out of gas. They also all have rings. A great example of this one is Saturn. We can see the rings from very far away. So that's a good example of a gas giant. And we're going to think, when we hear gas giants, something you can't stand on because it's not solid on its surface like the terrestrial planets are. So terrestrial, you can stand on, gas giants, you can't. All right, just to review also from yesterday, we talked about how the planets formed and why the terrestrial planets are so close to the sun. And I just wanted to review that quickly before we move on. And again, when the sun was forming, it had this big cloud of dust and particles and compounds floating around. And the stuff that was very close to it was a lot hotter because all the energy it was putting out was getting absorbed. So some of these gas compounds that were close to it stayed gas. But as you got further and further away from the sun, if we look right here, as it got further away from the sun, it got colder and colder. And then there was this point that we call the frost line where all sorts of things started freezing. So gases like water, uh, things like methane, ammonia, they started freezing into ices. And then that meant that those compounds could get added into the planetesimals that formed the planets. And so this graphic here shows you guys how there's a lot more material beyond the frost line for planets to form than there is inside the frost line. Out here we can see there is still some of the metals and rocks floating around, but there's a lot of these frozen compounds beyond the frost line that weren't there inside. And what this meant was that all the planets outside the frost line had a lot more material that they could grow from. All this material would bump into each other, it would stick to each other, and it formed bigger and bigger planets. So it ended up looking something like this. More material beyond the frost line meant bigger planets. Less material inside the frost line, smaller planets. Just to note, the size and distances of the planets here is not to scale, just to kind of show you briefly how it looks. All right, but here they are, real pictures of the 4 gas giants, Jupiter, Saturn, Uranus, and Neptune. And oops, oh, never mind. I thought I had Earth in there too, but not this one. Jupiter is the biggest of them all. It's known for this red spot right here, the giant red spot, which is essentially a gigantic hurricane that's always happening on the planet, or at least as long as we've been able to see it. Saturn is known for its gigantic ring. And then Uranus and Neptune were found much later. Both Jupiter and Saturn were found almost as soon as telescopes came around. However, Uranus and Neptune weren't found until about 100 years ago. So we actually know a lot less about those 2 planets than Jupiter and Saturn. We haven't had as much time to study them. So that's what they look like briefly on their exterior. And like I said, they're cloudy. You can definitely see that in Jupiter. And then Uranus and Neptune, not as much detail, but cloudy looking. And you can't stand on them. This is all gas on the surface. So this next slide, we're going to look inside the planets. And as a reminder here, I put all the terrestrial planets. Just to remind you that on all the terrestrial planets, they have a crust. That was their defining thing about them. They have a crust. That was the part that we could stand on. And then inside was a mantle, which is also solid. In the case of the terrestrial planets, it was rock and metal. And then at the very center, there was a molten core. And then in some planets, a solid inner core, which was inside of that was very hot, very dense. I wanted to show you this just to contrast it with the gas giants, which we have right here. And the first thing you'll notice, if you take a look at these cutaways, is there is no crust. The gas giants don't have a crust. You can't stand on them. They just have gas on the surface. There's no solids. On the very, very outside, we have things like hydrogen, helium, methane. These were the prominent gases and compounds when the solar system was first forming. And then on the inside, we get into this gray area, which is the mantle, just like the terrestrial planets have a mantle. Gas giants also have a mantle, but it's a little bit different. This one's actually made out of ices, of water, ammonia, and methane. So when I said that the planets, the gas giants formed out of those ices because they were beyond the frost line, that's where they ended up. They ended up in the mantle of the planets. And then at the core, they all have a core. It's surrounded by something called metallic hydrogen, which is actually not confirmed. It's just what we think is there. But then at the core, it actually is made out of the very same things that our planet is made out of, rock and metals. So that just gives you a brief look inside of the gas giants. I wanted to include this picture because just to give you an idea of the size of the planets. It says, who is the real giant here? With the sun obviously being much, much larger than even our biggest giant there, Jupiter. I think You could fit about 11 Jupiters across the sun, so it's still quite a bit bigger than any of our planets. And if we zoom in on it here, we can see all of our planets lined up. We've got Jupiter, we got Saturn, Uranus, and Neptune. And then if we zoom in even further, we can see our 4 little terrestrial planets. So this gives you a good idea of the scale of the planets and why we call them gas giants. Because you can't even see Mercury in the first picture. So moving on, we are going to look at how they are aligned in the solar system spatially by clicking this link. And you guys can come and look at this when you have time, and we'll post the slides too. So the idea of this here is to show you if the sun is 1 kilometer in diameter, where would the planets be in terms of how far it would be? So this sun is centered right about, well, it's pretty close to our school, but not quite. So it's right on the corner where like Starbucks and Walgreens is. Our school would be right here where all the lines start. So if our school is right here and the sun is 1 kilometer, that means that Mercury would be just down the road, right where, right, what is there? I think there's like a little school across the road from us here. So not too far away. If we go on to Venus, that's just past the stoplight, the intersection here on 7. If we look where Earth and Mars would be from the sun, that would be a little bit further down to Highway 169. If we look at Jupiter, that's going to be all the way into St. Louis Park now. So quite a bit further than our first 4 planets here. And again, the difference between Mars, the red one, is our furthest terrestrial planet. And then Jupiter is our first gas giant. And then we're going to have to go out even further to get to Saturn, which again, if the sun is 1 kilometer, Saturn is going to be all the way in uptown in Minneapolis. So we're getting pretty far away now. Uranus is even further. That's going to take us all the way out into St. Paul, so quite a bit of ways away. And then our last planet here, Neptune, is going to make it all the way out to Indian Mountains Park, which is beyond St. Paul even. So we're really getting out there. And now I want to show you where we're going next, which is what is beyond the furthest planet. One of them, of course, is Pluto, which we are not considering a planet anymore, and we'll get into that tomorrow. But there's something called the Kuiper Belt, which is an asteroid belt, and that goes out. It spans this whole blue region right here from Neptune all the way out to the end of this purple line or pink line. And that's the Kuiper Belt. And it turns out there's a lot of objects that look like Pluto out here in this area. And that's why Pluto got demoted, because they found there's over like 50 Pluto-like objects out in this range. And then if we go out even further to something called the Oort cloud, this would be the edge of our solar system. There's a big cloud of asteroids and dust around us. And we haven't traveled there yet, and we may never, but this is about how far it would be. It would reach all the way out to Upper Peninsula of Michigan. And if we follow that down, it would be past Illinois or into Illinois, past Chicago. If we go this way, it would be almost all the way out like Wyoming and whatnot, up into Canada. So it's really far away. And remember, our first sun was only 1 kilometer in diameter. And then, just to drive home how big and vast this universe of ours is, the nearest star we'd have to travel 6.7 times around the Earth to get to the nearest star. And I couldn't even do it on this program. And that's just to the nearest star, and there's 100 billion stars in our galaxy, and there's billions of galaxies. So that's just, it's crazy. I don't get it. All right, let's go back to the presentation. Here's your goal today. Again, we're just covering the basic components of the solar system. Today we studied the gas giants, and we learned a little bit about Jupiter Jupiter, Saturn, Uranus, Neptune. What I want you to do is on your last couple or your next pages, which should be 4 and 5, I want you to write about those 4 planets, include their diameter, their surface temperature, their mass, and then if you read about them in the links and you get some of that those stats from those planets, what advice would you give a traveler who's going to those planets? So your goal is, again, we're covering the basic components of the solar system, and today we're focusing on the gas giants, Jupiter, Saturn, Uranus, and Neptune. You're going to do just like you did with the terrestrial planets, diameter, surface temp, and the mass. You can find all of that linked in the Google Classroom assignment. So you guys got a lot of work to do. Go ahead and get to work, and I will see you tomorrow.